Two objects with masses of 3 kg and 5 kg are connected by a light string that passes over frictionless pulley, as in figure P4.38. Determine A, the tension in the string, B, the acceleration of each object, and C, the distance each object will move in the first second if both objects start from the rest. Okay, let's draw all the forces that works on this system, right? And I will start with this 5 kg here. And because this object is heavier, I think intuitively we know that the direction of movements will go there, right? So this is the direction of movement. So I want the one that is on the direction of the movements here to be positive, and the opposite of that will be negative, right? But if this object is going down, this object here are going up. No, is going up. English grammar is hard, right? So this is going down and this is going up. Good. Now let's draw all the forces that works on this object first. So obviously we have the weight of it pushing is down. So I will have FW1 here, the force by the weight of this first object. Okay. But then we have the opposing force here, which is the tension of the rope, right? So we will have this one here. Let's name this as T. Good. And that is all the forces that works on this object. And now let's apply the Newton's second law to this first object, right? So we will have sigma F is equal to the mass times acceleration. Good. And the positive one is the one that is to the direction of movements, which is this one. So I will have FW1. And to the opposite direction, we will have the minus sign. So I will have T there. Okay, and the mass will be the first mass here. And that will be mass number 1 times acceleration. Good. And now we will have mass number 1 here multiplied by G. That is the weight of this block, right? And so we'll have minus T, and that will equal to mass number 1 times acceleration. Okay, now let's plug in all that we know. Mass of 1 is 5 kg, G is 9.8, okay, and then minus T, and that will equal to mass number 1 is 5 multiplied by A. And let's isolate all the variables to one side. So I will have T plus 5A. But on the right hand side, we will have 5 times 9.8. And that is 5 times 9.8. That will be 49. Okay, we'll have 49 here. And I think nothing that we can do from here. Let's save this as equation number 1. Okay, now let's draw another forces that works on this object here, the 3 kg object, and obviously it has its weight, so we'll have FW2, and here this one will be pulled up by this string, right? And remember that we have the same string as this one, so the tension should be the same. So here it will be pulled up here by this T. However, what is the difference? The difference is this is moving up. So in the Newton's second law here, sigma F is equal to mass times acceleration. It is moving up, so the positive one is this T. And then the negative one is the weight, right? So I'll have minus FW2. And that will equal to mass number 2 multiplied by the acceleration. Because they are moving together, the acceleration will be the same. So I'll have A here. Good. So now we'll have T minus weight of this one, which is mass of this object multiplied by G. And that will equal to mass number 2 multiplied by the acceleration. So we'll have T here minus mass number 2, that will be 3. And then multiplied by G, we will have 9.8. And then that will equal to 3 multiplied by A. Let's isolate all the variables to the left hand side. So I have T minus 3A. and that will equal to 3 times 9.8. 3 times 9.8. And that will equal to 29.4. 29.4. And that will be our equation number 2. And now, from equation number 1 and equation number 2, we can calculate T and A, right? And we can just use calculator for that. What is our T? So here we will have T plus 5A is equal 49. Okay, let's set this up as equation solver, which is number 5. And two variables is number 1. And we'll have 1, and then 5, and then 49. Good. And then the second one here, the second equation, we will have 1 minus 3, and then 29.4. Good. And we will have the x value as the tension of the rope, and that will be 36.75. And the unit here will be in Newton. And that is the answer for question A. And for question B, we need to find out the acceleration, A here, and that is the y value here, right? So that is a system of equations. So we will have this one is 2.45. 2.45, and the unit will be meter over squared second. And that is the answer for question A and B. And then C, the distance of each object will move in the first second of motion if both objects start from the rest. Okay, so how far it moves, right? So we have this distance here. Let's name this as y. It should be the same, right? Because they have some same acceleration and they are moving together. And then let's calculate that y here. So we will have y here. We can use kinematics. So I will have P0 multiplied by t, and then plus 1/2 multiplied by the acceleration multiplied by t squared, right? But what is the time? It is on the first second. So that means that we have our t here is equal to 1 second. Let's plug that into the formula here. Y is equal to the initial velocity, and that start from the rest. So that means the initial velocity is 0. And then t is 1 second. So we'll have 1. And then plus 1/2 multiplied by the acceleration, that will be 2.45. So I have 2.45, and then time, that will be 1, and also that is square. So we'll have the distance here is equal to this one. 0 times 1 is 0, plus I think we will only need to calculate this one, 2.45 divided by 2. And what is it? 0 plus this one, it is just this one, 2.45 over 2, but I think I need the help of calculator to calculate this one. Okay, let's set this up, and computation is number 1, 2.45 divided by 2, and that will equal to 1.225, 1.23 I think meter. And that is the answer for question C. Okay, so we obtain all the answer for this question. The tension of the rope is 36.75. The acceleration is 2.45. And the distance it moved, that will be 1.23 meter in the first second. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye-bye.